Assalamualaikum, I am from Group 8 and we choose Sellafield Nuclear Incident. I would like to introduce all my team members. Firstly is me, Siti Nur Syamimi binti Muhammad Azman. Second, Nur Ain Afika binti Azhar. Third, Iman Munirah binti Yusriman. And lastly, Diva Mani anak lelaki Zivani Sain. Next, I will briefing about Sellafield background. Sellafield background. Sellafield is a larger multifunction site close to sea scale on the coast of the Cumbria, England. As for August 2020, activity at the site include nuclear fuel reprocessing, nuclear waste storage, and nuclear demonstration, and it is a former nuclear power generating site. The licensed site cover area of 295 hectares and comprises more than 200 nuclear facilities and more than 1,000 buildings. It is Europe's largest nuclear site and has the most diverse range of the nuclear facilities in the world, situated on the single site. Sellafield site incorporates the UK first generation nuclear reactor and the associated fuel reprocessing facility at one scale, and the world's first nuclear power station to export electricity on the commercial scale to a public ground at the Garden Hall. The UK National Nuclear Laboratory has central laboratory and headquarters on the site.
Assalamualaikum. My name is Nur Ain Afika. I will present about one of the accidents of Sellafield. Sellafield was the site in 1957 of one of the world's worst nuclear incidents. This was the wide-scale fire which occurred when uranium metal fuel ignited inside wide-scale pile number 1. Radioactive contamination was released into the environment. One of the incident wide-scale fire is ignition. 7 October 1957, operator of Pile 1 noticed that the reactor was heating up more than normal. A Wigner release was ordered. This had been carried out 8 times in the past, and it was known that the cycle would cause the entire reactor core to heat up evenly. During this attempt, the temperature enormously began falling across the reactor core, except in channel 2053. The temperature was rising, concluding that 2053 was releasing energy. On 8 October, second Wigner release. This attempt caused the temperature of the entire reactor to rise, and it's successful. 10 October, the temperature in the core was supposed to gradually fall as Wigner energy release ended, but one thermocouple indicated that core temperature was instead rising. In an effort to cool the pile, the cooling fans were sped up and airflow was increased. In conclusion, this was the source of the anomalous heating in channel 2053, not a Wigner release. Thank you.
Hello, my name is Iman Munirah. When they decided to speed up the cooling fan, it caused fire. This happened because speeding up the fans increased the airflow in the channel, fanning the flames. The fire spread to surrounding fuel channels, and soon the radioactivity in the chimney was rapidly increasing. A foreman, arriving for work, noticed smoke coming out of the chimney. The core temperature continued to rise, and the operator began to suspect the core was on fire. Operators tried to examine the pile with a remote scanner, but it had jammed. Tom Hodges, second in command to the reactor manager, suggested examining the reactor personally, and so he and another operator went to the charge phase of the reactor, clad in protective gear. A fuel channel inspection to plug was taken out close to a thermocouple registering high temperatures, and it was then that the operators saw that the fuel was red hot. There was now no doubt that the reactor was on fire and had been for almost 48 hours. As you can see, Thomas Tuohy was deputy to the general manager at the Windscale nuclear facility, when a major fire erupted on 10 October 1957. He was the leading participant in effort to put out the fire, which was emitting radioactive contamination into the air, and so played a key role in minimizing Britain's worst nuclear disaster. After that, the operators were unsure what to do about the fire. First, they tried to blow the flames out by running the fans at maximum speed, but this fed the flames. Tom Hodges and his colleague had already created a fire break by ejecting some undamaged fuel cartridges from around the blaze, and Tom Twohy suggested trying to eject some from the heart of the fire by bludgeoning and the melted cartridges through the reactor and into the cooling pond behind it with scaffolding poles. This proved impossible, and the fuel rods refused to budge, no matter how much force was applied. The poles were withdrawn with their ends red hot, one return dripping molten metal. Hodges knew this had to be molten irradiated uranium, causing serious radiation problems on the charge hose itself. Second attempt was carbon dioxide. The operators tried to extinguish the fire using carbon dioxide. The new gas Calder Hall reactors on the site had just received a delivery of 25 tons of liquid carbon dioxide, and this was rejected up to the charge phase of Windscale Pile 1, but there were problems getting it to the fire in useful quantities. Then, they used water. On the morning of Friday, 11 October, when the fire was at its worst, 11 tons of uranium were ablaze. Temperatures were becoming extreme, and the biological shield around the stricken reactor was now in severe danger of collapse. Faced with this crisis, Twohy suggested using water. This was risky, as molten metal oxidized in contact with water, stripping oxygen from the water molecules and leaving free hydrogen, which could mix with incoming air and explode. Tearing open the weakened containment, faced with a lack of other options, the operator decided to go ahead with the plans. About a dozen fire hoses were hauled to the charge phase of the reactor. Their nozzles were cut off and the lines themselves connected to the scaffolding poles and fed into fuel channels about 1 meter or 3 feet above the heart of the fire. Twohy once again hauled himself onto the reactor shielding and ordered the water to be turned on. Listening carefully at the inspection holes for any sign of hydrogen reaction as the pressure was increased, the water was unsuccessful in extinguishing the fire, requiring further measures to be taken. Then Twohy ordered everyone out of the reactor building except himself and the fire chief in order to shut off all cooling and ventilating air entering the reactor. By this time, an evacuation of the local area was being considered, and Twohy's actions was the workers' last gamble. Twohy climbed up several times and reported watching the flames leaping from the discharge phase, slowly dying away. During one of the inspections, he found that the inspection plates, which were removed with a metal hook to facilitate viewing of the discharge phase of the core, were stuck fast. This, he reported, was due to the fire trying to suck air in from wherever it could. He finally managed to pull the inspection plate away and was greeted with the sight of fire dying away. Water was kept flowing through the pipe for a further 24 hours until it was completely cold. After the water hoses were turned off, the now contaminated water spilled out onto the forecourt. The reactor tank itself has remained sealed since the accident and still contains about 15 tons of uranium fuel. It was thought that the remaining fuel could still reignite if disturbed, due to the presence of pyrophoric uranium hydrate formed in the original water dosing. Subsequent research conducted as part of the decommissioning process has ruled out this possibility. The pile is not scheduled for final decommissioning until 2037.
Hi guys, Namaste Devmani Analaki Sivanesan. The health and environmental effect of Sellafield nuclear accident is the wind-scale fire and ensuing fallout are estimated to have caused at least 190 cases of cancer, more than half of which were fatal. The marine environment of the Irish Sea also suffered from the disaster, as well as from countless other spills, leaks, incidents, and the deliberate or accidental discharge of the radioactive effluent. In 2004 and 2005, 83,000 of liters of radioactive acid leaked into the North Sea, containing carcinogens such as strontium-90 and caesium-137. Through bioaccumulation in the marine food chain, the substance pose a grave threat to the fishing regions around the Great Britain, Norway, and Ireland. Even the pro-nuclear International Atomic Energy Agency has to admit the wind scale was a major contributor to radioactive pollution of the Atlantic Ocean. Increased level of the radionuclides such as cesium-137, cobalt-60, and americium-241 were also found in soil samples around the complex, suggesting radioactive contamination of agriculture products for human consumption. In 2002, a British study also found that children of the Sellafield workers have a nearly doubted risk of developing leukemia and lymphoma in their genetic. Thank you for my part.